So if you remember, power is energy per time. And this is kind of, energy has a lot of representations. It can come in the form of work that, supplied by something, or it can come in terms of energy consumed, like in a resistor in a car engine or something like that. And so it's just a general term, but we're going to apply it to circuits here. And if you remember, we can say, look, the voltage is the energy per charge, right? And so the energy is the charge is equal to the charge times the voltage, or electric potential, as we used to call it. And so, if a battery is like 10 joules per coulomb, is a 10-volt battery, or 12 joules per coulomb for a 12-volt battery. If I multiply that by charge, that tells me how much energy I get. So if I pull 2 coulombs from a 9-volt battery, I get 2 coulombs times 9 joules per coulomb, which is 18. Did I say a 9-volt battery? 2 coulombs times 9 joules per coulomb gives me 18 joules, right? So I can say, for example, the energy is 2 coulombs times 9 volts, which is equal to 2 coulombs times 9 joules per coulomb, which gives me 18 joules. So if I pull 2 coulombs out of a 9-volt battery, I can get 18 joules of energy out of it, or do 18 joules of work if I want to, right? And so for electric circuits, I can say, look, this is Q times the electric potential, or voltage, divided by the time. But Q divided by time, this is just telling me how fast I'm pulling charges out. And so this is just the charge per time times the voltage, which is just the current times the voltage. And so if you have a circuit with a voltage V and a current I, then the power it's supplying, the energy per time, is just the product of those two. And since we have Ohm's law, then I can say, look, power is equal to V over R times V, or just V squared over R, right? If I replace this I over here with V over R, I get V squared over R. Or I could say power is equal to I times R, because this can be arranged to V equals I times R, right? And then I can substitute this guy in for this guy and get this, and I get I squared R. And so in an electrical circuit, I can say power is equal to VI, or it's equal to V squared over R, or it's equal to I squared R. In an ohmic circuit, right? If the behavior of the circuit is ohmic. And so we'll use these in a few examples. So I can say, what is the power consumed by a 10 ohm resistor carrying a current of 2 amps, right? So here's my resistor, and coming through that resistor is I equals 2 amps, right? And the power, since I have the current and the resistance, right, I can use the I squared R version of the power, and so that's 2 amps squared times 10 ohms, which is 4 I'm getting there times 10 watts, which is 40 watts, right? An amp is a coulomb per second, and an ohm is a joule. An ohm is a volt per amp, which is a joule per coulomb per amp. And so I have amps squared times ohms. If I break these down a little bit, amps squared times ohms is coulombs per second squared times joules seconds per coulomb squared. And so these two guys cancel, right? And this is going to be a 1 over second squared, and this is going to be a second, so this is just going to be joules per second, which is watts, which is what we put here.